In this video, we're going to look at how the factor theorem is another way to use synthetic division to determine if a polynomial has a factor of x minus k. So, the factor theorem just says the polynomial f of x has a factor x minus k if and only if f of k is equal to 0. So this is going to be important for all the factoring that we are going to be doing with the polynomials, and we're going to take a look at two different ways to look at this. We're going to find f of k and see if it equals 0. We're going to use synthetic division using the factor x minus k and see if the remainder comes out to be 0. So in our first example, it says determine if x minus 2 is a factor of f of x equals x squared plus 2x minus 4. One way to do this is by direct substitution. And the other way to do it is by synthetic division. So we're going to do both. If we have a factor of x minus 2, that means that the value that we would plug in would be the opposite sign x equals 2. So you always switch the sign whether you're going to substitute or whether you're going to do synthetic division. So we're going to find f of 2. So it's going to be two squared plus 2 times 2 minus 4. We end up getting that f of 2 is equal to 4. Our goal is to see if it's going to come out to be 0. So since f of 2 does not equal 0, that means it's not a factor. We could do the same thing using synthetic division instead. Hopefully left some space for this other option. You can either put these side to side or one right under the other. Same thing with synthetic division. The 2 that we're going to use is a positive 2. We're going to list our coefficients out and do synthetic division. Bring down the 1, multiplied by 2, add that, multiplied by 2 again, and add, and you get a remainder of 4. So you'll notice the remainder comes out to the same answer as if you evaluated it. Since that is not 0, it's not a factor. We're going to do one more so that you can see what would happen if it is a factor. But those are your two options. So our next example, determine if x minus 1 is a factor. Again, we would look at when x is equal to 1. If we plug that in, we would do f of 1. I'm not going to do color coding on this, too complicated to keep going because there's 3 spots to plug in. So 1 cubed plus 2 times 1 squared minus 1 minus 2. If you plug it in, that does come out to be equal to 0. And if you do synthetic division, little snafu here, everyone, real quick. I just got to fix that. 1 times 3 is 3, not 4. I get 2, 2 here, and then 0. So in both situations, you either get that it's equal to 0 if you were to plug in by direct substitution, or you get the remainder of 0 if you use synthetic division. So yes, it is a factor because we're getting 0. And actually, if you wanted to, you can factor this even more. And this is something we're going to go further with later on, but just to kind of show you where this is going and how this is helpful for factoring. This means x minus 1 times x squared plus 3x plus 2, because that's the result you would get from synthetic division, is a factored form. It's not completely factored, but it is a factored form, so remember to add your variables back in. You would go right to left and add them in as you go. And you could actually factor this piece a little bit further here into x minus 1 times x plus 2 times x plus 1. Now, you don't have to do that in this problem. All you have to determine here is that it is or is not a factor. But I just wanted to show you where we're kind of going with this idea of the factor theorem.